Thanks, appreciate it. So, I'm Anothony Eden, founder of KBSimple, as it says up there on the board. And today, I need to go back in time just a little bit to sort of set the stage for this talk, and I'm going to be moving around a bit, so I hope you all don't mind. I like to get down on the floor and all that. I like being at the level here. So a little bit of background. I've been doing this for a little while, doing programming, specifically doing web programming for a little while. And in 2001, I was doing mostly Java. And in 2001, everybody, like Java, we had servlets. And I think struts was just coming out. And I was going to change the world by building my own web framework. That's right. And I did. I actually built a web framework and built it up over time. It was called JPublish. It had all the hotness, all right? It had, like, you could script the controller levels. You had scriptable actions. It had all kinds of, it was extremely extendable. You could do JSP, or you could do velocity, or you could all do these other things. Any of you old-time Java people will know what I'm talking about. So I used that for quite a while, but in 2005, I started to get this feeling that things were getting stale. The Java ecosystem, especially around web development, was just getting stale. There was a lot of push towards enterprise Java beans and massive frameworks and layers upon layers of patterns. I was picking up software contracts where there were so many patterns in there that you actually lost the fact that they were doing a database query on an unindexed table. And that was what was causing all the performance issues. So it was crazy. We were trying to solve everything with these patterns. So in 2005, I got wind of Rails. This is a relatively new up-and-coming framework. I had dabbled a little in Ruby before. I thought, oh, this is cool. I'll go take a look at this thing. In 2006, I went to the first ArrrrCamp, and everything was new and exciting. Here we had a framework that was opinionated. Okay. We had a framework that was opinionated. We had a framework that basically said convention over configuration. So these things that were sort of the antithesis to the world of Java. And so this was exciting. This was really, really interesting because it felt so fresh. The interesting thing as well is that just prior to this, I had come full cycle. Remember I mentioned I built my own framework? Well, by the time I left Java, I had gone back to just servlets and JSP. Because it turns out that I was over-engineering everything. A lot of it was my own fault. I was so excited by the notions of building these complex systems that I actually caused myself tons of headaches. And Rails was the breath of fresh air because it simplified a lot of things that I had made really complex. At first, I was not a believer, by the way. When the whole 10 times productivity thing came up, I said, there's no way this is possible. And then I started building things with it. And I started realizing, you know what? This actually is possible. So that was 2006. And essentially, for the next 7 years, I was building Rails applications. And initially, I thought, okay, you know, Rails is going to follow the same pattern. I'd been seeing this pattern over and over again. Things start off simple, and they eventually gain complexity. That's what happens, right? Everything starts off pretty simple, and as more and more people touch it, the complexity rises, and therefore we get these complex systems, and eventually there's a breaking point. And so my development cycle was always, you know, get more and more complex, and then have a massive reaction and go back to the most simplest thing I possibly could, and then restart the cycle. So in 2013, we decided to start a new project. 2010, we'd already built KBSimple. We've been working on it for the last 3 years. It's doing well, and we found a need for something that we couldn't find. We couldn't find something that satisfied what we wanted, which was a simple knowledge-based system, not tied together with a support system, just a simple knowledge-based system. We wanted to basically have what Heroku had for their documentation and what GitHub was working on for their documentation. So we decided, okay, we'll try to build something really simple, and we'll go ahead and work on making it into a little product. All right. At this point in time, we had the possibility to choose a whole slew of possible tools. We could use Rails, we could use Sinatra, we could use just Rack if we wanted to. We could go to another language, we could use Django, we could go over to Node.js, we could start looking at some of the new hotness. You know, we could do what we want. And so we said, oh, we can do all this, but is that really going to solve our problem? So we look back at Rails, and we said, no, we're going to do this with Rails. And there's a reason. Because 7 years later, Rails was still not stale. Okay, if anything, Rails still feels like it's good for developing these. It's basically good for solving problems which involve a web interface that you have forms on, and then you persist data into a database. I mean, it does that really well. And so I started thinking about this after we built the product. It took us 6 weeks to build the product, and I wanted to understand why it didn't feel stale. Like, how did they manage to go 7 years with this framework? And I still feel that it does a pretty good job at what it does. And here's some of the thoughts that I came up with. The first is the libraries around Rails. So in the world of Java, when Hibernate came out, everyone was like, this is awesome. And Hibernate has lasted for a long, long time. And other things have come and gone, but Hibernate has been around for this long time. Now, that actually has some benefits, kind of like the way Rails has been around for a long time, but there's also some disadvantages. The libraries, it's really difficult to completely advance the thought around a library without sometimes throwing things away. And so what's interesting in the Ruby world is that I think our libraries have gotten, in a lot of cases, better over time, all right? We've seen them get complex, then simple. They've gone through their own cycles. So I think the first thing that keeps Rails still fresh is that there's plenty of libraries out there that you can use to simplify your applications. An example is Simple Config. It's a very basic library that will make it easy to configure the internals of your, like the domain-specific configurations of your application. So that's just one example of a library. So libraries was the first thing. The second was documentation. Rails documentation was pretty bad for a long time. It was community-based documentation. The community was doing everything to sort of push the Rails engine forward. Well, a few years back, the Rails guides started. And the Rails guides have done massive amounts to improve the documentation around Rails. The Rails API documentation is still good. It's not excellent, but it's still pretty good. But the fact is that there's still an ongoing belief that we have to do better at documentation. So continuing to develop the documentation, even as the framework develops and changes over time, I think is another thing that's kept it from getting stale. The third thing is the community, and I think this is the biggest reason why Rails today is still valuable, and it's because of all of you. It's because the people in the Ruby and Rails community are nice, generally. But worse is, they know they're fallible, and they're willing to accept it, and they're willing to talk through their issues, whether it comes from a technical or social standpoint. We're not afraid to bring those issues up. And I think this is important because other communities in the past, maybe not so much, they were getting better at this in general as software developers, but for a long time, communities were really closed. You could not easily break into a community. All right. So, for example, in the world of Java, you had these little breakout communities, and if you weren't doing it their way, then your way was wrong. You know, you're just wrong. That's what it came down to. And I think in the Ruby community, there's an openness to say, I think you might be wrong, but let's go ahead and figure this out together. So, and then of course on top of that, we have great conferences. We have little conferences all over. We have big conferences. I mean, we have a strong community. So, a solid community keeps the framework from getting stale as well. So those are the things that as I started looking at why didn't I feel this way yet about Rails? I didn't feel like I had to jump ship and go to a different framework yet. I didn't feel that I had reached that peak of complexity. The other thing that's interesting about Rails is that they keep pulling stuff out of the framework. And at first you're frustrated. You're like, why do they pull this library out of the framework? I depend on it. And the reason is because they see the complexity bubbling up into the framework, and they want to remove that complexity to keep it fresh. And it's frustrating, but ultimately, for some reason, they've done a good job of making good decisions for the most part. All right. So another thing that's nice about Rails is it didn't really try to become anything that it wasn't. The core of the framework's still just MVC, right? I mean, basically, you model your problem in your domain model. You control the flow of requests and responses through your controllers, and you view the outcome in your views. I mean, it hasn't changed much. You know, the last talk before us, we talked about some of the patterns for sort of making sure that you can continue to develop code so it doesn't grow to be monolithic code, and that includes breaking up models into either more object-oriented designs, or the same with controllers, or putting things in concerns and stuff like that. But look at how long it took for concerns to become an official part of the Rails framework. We're going to Rails 4, and only now is this idea of, okay, maybe the models actually, maybe we need something that's going to be the official way to add cross-cutting concerns. So I think that's really good. But the fact is that they've still kept the MVC as the core of the framework. All right, and they've gotten rid of so much other junk as well. Think about, does anybody here, you probably remember plugins. There was a time where to put plugins in Rails, you had to put stuff in the plugins directly, and it was difficult. And they just eventually said, you know what, Gems does this for us, so we'll just use Gems. Okay, great. So they actually pulled out chunks of complexity. All right, so back to the idea of bootstrapping, and I did talk about this, about being, Rails is still the best framework for bootstrapping, and when I say that, what I mean for bootstrapping a new project. That could be a project that you want to charge money for. It could be an internal app that you're using to support other people inside your company. It could be something just for fun that you're building for yourself. If you're building a web framework with an HTML front end, I still think it's the best way to do it. And here are the keys. Now, this is actually applicable, I think, to any sort of thing that you're building. All right, but it's especially applicable to, screw it, it's applicable to anything. So these are the keys to your success if you're going to bootstrap something and you want to minimize the amount of pain that you have, the pain and suffering for getting this thing built. Number one, have a problem, solve a problem. All right? That seems obvious. Okay, I have a problem, I should come up with a solution for it. Notice what this doesn't say. It doesn't say have a problem, engineer the best solution to the problem. That's not what it says. It says if you have a problem, you solve a problem, all right? Sometimes the best solution to solving a problem is the least engineered solution, because that problem may be only short term. You may only have this problem for a little while. Or maybe you want to solve this problem because ultimately you come to realize when you build it, you're like, this is actually something bigger. And so therefore, I now have a little piece of the solution, but I can legitimately throw it away and start thinking about a bigger, like solving a larger problem. So the first thing is have a problem, solve a problem. Second is cut the cruft. This is actually related to the first. It's really easy when you start thinking of your solution to a problem to say, well, I have this problem. It needs feature A, B, C, X, Y, Z, and if it doesn't have that, then clearly it is not solving my problem. Oh, and by the way, it has to parse Wikipedia, right? I mean, it doesn't have to do all this unless your solution is actually you need to parse Wikipedia, in which case you would. But for most other cases, what you have to do is you have to be really vicious and cut out what you're thinking of making. You just have to cut. I mean, essentially, if you're thinking about a film, you're making a 30-minute film. There's going to be 6 hours of film on the cutting room floor that you're not even going to use. All right, and that's okay because again, the idea is to solve a problem. So you cut the cruft. The third one is though, don't cut the tests. It's really easy to, and I'm going to be the first one to say I still write code sometimes without tests. Okay, it happens. And there's a reason, because usually that code's a one-off thing, all right? I may be feeling through the problem, I don't fully understand it, so I might do this. Fortunately, I have a pair, essentially, who usually reels me back in and says, we need to test this before it actually goes to production. Okay, fair enough. So ultimately, what I'm suggesting is, if you're cutting the cruft, don't sacrifice the tests, especially in a Rails app where testing is so baked in to the framework. There's really no reason not to test the majority of the logic inside of your application because it's all the tools are right there for you. Whether you use what's built in or switch over to RSpec or whatever, or mini tests, doesn't much matter. The point is that you shouldn't be cutting that because the tests, like this picture, all right, that's you, that's a test. You test. Imagine they're not there. You're going to have a painful landing here in just a few minutes. So before you're taking stuff to production, make sure you keep the tests in there. One other suggestion I have is, let's say you think you might need features, or you implement a feature that seems to be straightforward, but you're not sure yet whether it has value. Prep it by putting a feature flag around it. This will save you a lot of time later on. Essentially, what a feature flag says is, can the current visitor use this feature? It's as simple as it is. There are libraries out there you can use to do this, to like basically wrap a simple feature flag. It's really not that hard as well to do it inside just one table in a database. Take a look at that on request time and determine whether they can see that feature. So feature flags are going to save you a lot of time in the long run. Plus, if a feature, if you actually build something that's successful, but your feature kind of sucks, and you have it running, but you're finding problems with it, you can always turn it off as well. So that's really useful. This has helped us immensely in our projects to have feature flags. The final thing is you got to launch. All right, this is the solve the problem part. You can't just build it and build it and build it and build it. That's not what you want to do. If you want to bootstrap something quickly, you have to focus on getting it out there, launching it. One of the things that helps you get to launch faster is services, software as a service. All right, if you're not taking advantage of it, then you're spending time building things that aren't core to your business or core to solving the problem. So take advantage of it. For example, billing software. There's no reason that your initial implementation should have its own billing software, unless you're making billing software. Other people have already done that. Stripe, if you're in the US and now actually all over, they're in France, Belgium, UK, so that's good. Stripe's an option. They will save you a lot of time dealing with taking the customer credit card data, protecting it, making you compliant with regulations, sending out notifications when payments get done automatically. All these things are things that you don't initially want to build. Now, the other one, by the way, we use a lot is Chargeify. Chargeify is a US-based one. You can actually have Chargeify sit on top of Stripe if you really were like, I want Chargeify's features, so they've got some features that Stripe doesn't have. The point being is that by taking advantage of these billing things, I don't have to worry about it in my first implementation, but later I can always augment it or replace it if absolutely necessary. So, software as a service billing. Error notification. You shouldn't be receiving emails for error notification. You shouldn't be letting them go anywhere. There's plenty of software as a service out there right now, or you can install your own tools if you want to. But the point is, use something that collects and aggregates those errors together. We use Bugsnag, which is a good one. There's also Honeybadger, and there's a bunch of other ones. There's new players out there, other than the older ones that you might remember, like Exceptional and Airbrake, that are, at this point, somewhat disappointing. So there are new options, and there are people that are trying to, because as good as you are, because I know you all are awesome programmers that write tests and have perfect code, your buddy who's programming, he's going to introduce an error, right? So you got to catch his errors. So anyways, use a software as a service for this. Logging, same deal. We use Papertrail.io. That's a great service for aggregating all of your logs together. You need to be doing this if you have more than one location where you're collecting logs. Customer support. All right, we use Intercom.io, great tool. Again, that may be too much for you, but at least look into some of the software as a service solutions for customer support as well. So, everybody's sold that Rails is still the best framework for bootstrapping apps. But, there's just got to be a but here, right? When should I not use Rails, right? And by extension a little bit, when should I not use Ruby? I'm going to take this a little bit further, but it's mostly when should I not use Rails? And let me go for the first example. If resources matter, so what I'm talking about is CPU and RAM matter to you, Rails probably isn't the best solution for you right now, okay? Ruby as a language was designed for developers. It's optimized for developer happiness. It's not optimized for machine happiness. All right, so therefore, it's going to use a lot of resources, both RAM and CPU. So this is the first case where you probably don't want to be using Rails. Now, if you're building a web app with an HTML front end, most likely resources, it's not as critical initially. You can pop it up on Heroku for the first implementation. Everything's good. Another example is when latency matters, because Rails is latent. It's got a lot of latency in it. You've got a lot of things usually to get from the start of the request to the end of the request. The library, the framework does great things for you, but it also adds a lot of overhead. All right, and so there's certain areas where it doesn't make much sense. How are we doing on time? Are we? Okay, good. I'm moving along exactly how I wanted to here. This is perfection. So these are two examples. There are other examples as well, but I'm going to go a little bit deeper into each of these right now. So, I'm going to tell you a little bit about Go, because it's a Ruby conference. So let's learn about some Go. So Golang is a language created at Google, and it does some things pretty well. You ought to consider it for certain things. And the first example of something I'd consider it for is this. All right, if the consumers of my service are doing so via an HTTP API, and so they're passing JSON or XML, most likely JSON at this point, back and forth, then I don't really need all of the things that Rails offers, all right? Because Rails is really good about the MVC. It's about the viewing part of it. The views don't matter as much because the views can be created just from a simple data structure, all right? So Go is optimized for resource usage. It's fast. It's really fast. It's fast. It uses very little CPU, and it uses very little memory. It will not load a dependency. It won't even let you compile if you have a dependency that's defined with no code using that dependency. So if you define, you say, I want to import this package, and you never use it, the compiler won't compile. All right, so it's optimized around the idea of resource. It's also optimized for delivering web services. It's got a built-in HTTP server that's actually pretty good. It's got built-in JSON parsing. So as a language, it's designed to serve web services, among other things. It also has some concepts in it for parallelism that are important as well. I wanted to show you a little bit of code, because some of you may have never seen any Go code. And I want to show you, the thing that's interesting about Go is it's boring. As a language, it's exceptionally boring. There's nothing fun about it. All right? It was like, it's the code that the 50-year-old uncle who has been a coder all his life wrote. I mean, this is what he wants, right? It's basically a variant of, it's almost like a variant of C. There are some niceties in the syntax that they've done, but it's a very boring language. So let's take a look at this. So in the beginning, you describe your package. This is the main package in this case. They do a lot of stuff then so when you import packages, this is saying I need the net HTTP, so this is saying it's a standard lib, or that it's in my Go path, which is where you're looking for libraries. And then they also have this where you can say, and I need to have this dependency on this remote project. And then you run a command that's called go get, and you can actually go get, it'll go grab all of your remote packages, bring them in locally, and it will deal with upgrading them. Basically does dependency management built in. I have to actually use these, though, in my code in order for it to work. Otherwise, like I said, it won't compile. Inside of Go, the data structures are simply structs. So essentially, you're saying, any complex data structure that's not a basic type is going to be a struct, and a struct just consists of other fields. That's all it really is. In this case, the type is a zone notification. A little bit about this code is coming from a zone server that we have inside of DNSimple that actually is used to push and pull zone data to our name servers all throughout the world. And this is basically just a notification that we send out over WebSockets that says, hey, this zone has changed somehow. And it's pretty straightforward. This is the name of the field. Anything that's uppercase is going to be publicly available outside of its context. Anything that's lowercase will not. So this type is available outside of this package if it needs to be, as are these fields. These are available through instances of this struct. The type is a string, and then this is a little bit of metadata that is used by the JSON generator to basically just produce JSON afterwards. If you didn't have it, it would do things like it would use the capitalized version of name, which is fine if you're doing inner Go processes, but if you're doing, in our case, we use Erlang to Go, then it's not, we just don't want that syntax there. So we can actually mark it up with metadata. This is another type here. This is an internal one. You see that's lowercase. And in this case, it defines these fields, which are also internal inside of this package. It defines 3 channels, and channels are the way that Go passes data back and forth between Go processes. Go processes are the way that Go breaks up its code, like it's basically how the code runs. So you can basically say, go run this chunk of code, go run through it, and it'll do it off in a separate process, and it won't wait for a return value. And you can use channels as interprocess communication. All this is inside the Go environment as well. We're not talking about processes in the OS. All right, and so this one says, well, I want to know who I'm broadcasting it to. Give me all the connections, the connections there, and I have a way to say I want to add a new connection and remove a connection from it. In this case, I instantiate the hub right there. I make channels. I basically create in memory all those things. And then this is finally a function. This will be the most complicated thing you'll see. This is a function. It's actually declared in the package as a function. This one, because it's lowercase again, is only available inside of the package. It says I take a hub, like a reference to a hub, and that's basically a pointer to the hub, and I take that in as h. And then indefinitely, there's no while, for, all these other, there's only one type of loop in Go. It's the for loop, and it can be used for everything. So this form of for basically says, just do this indefinitely. And then it's basically it's a case statement right here. And it basically says, okay, if there's something that came in through the register channel, pull it off and add, basically say, okay, I'm connected. If it unregistered, it will delete it, and it will close that channel. And then this other one says, I want to broadcast, which says, okay, for all of the connections, run through every one of those connections and send it the message that needs to be broadcast, if there's a message. Otherwise, it will say, oh, I can't actually connect, so therefore I'm going to close down the WebSocket, and the WebSocket will have to reopen from the other end. So that's a bit of Go code, all right? Go is great when you want really lightweight processes that use very little RAM. We use it for the zone server that I was talking about. We use it for URL redirection. We're also working on some new tools that use it that we want to deploy out to nodes that we need them to be on nodes that do other things, but we don't want them to take up much space, right? So if you're thinking about, in this case, it's monitoring. If you want to monitor the behavior at a node, then having this really little thing that's running is nice. Erlang. I love Erlang. I'm going to show you a little bit about Erlang right now, too, because one language isn't enough to mess with your minds. Let me give you a second one, the one that will blow your mind and go, what the hell did Anthony just show me? So we use Erlang for authoritative DNS. This is Erlang. Erlang is purely functional language, and what's cool about Erlang is they've designed it around the idea of lots of processes that run for a long time that communicate with messaging. That's what it is, all right? So in Erlang here, I'm going to go through these one by one. This is essentially the header area. Let me go through this here real quick. Same thing. In Erlang, you define a module. So the module is a namespace. Erlang has flat namespaces. A behavior, so this basically says this thing acts this way, and therefore it expects it to implement a set of callbacks. All right, and that means that essentially what we're saying right here is this defines the behavior for a process that's going to run independently in memory. All right, and that process, the only way we can communicate with it is through its mailbox to message it stuff. And then we export these public functions here, basically saying that I can do ErlDNS packet cache, call start link, which will actually start the process. I can get something out of the cache, I can put something into the cache, I can sweep the cache to get all old cache items, and I can clear the cache to wipe everything out. So basically what this is exactly like it's a simple in-memory cache, right? But it's one that's all inside the Erlang VM. It is designed specifically for caching DNS packets, but that's what it is. That's the public API right there. In addition, we have the gen server hooks, so these are what's going to be called to the running process when things are invoked on it. And then finally, we have right here, they're defining some constants, essentially. It says, the sweep interval, for example, is every 10 minutes. And this here is a record. A record is essentially like it's just basically a tuple, which is basically like a set of things, where each one has a name. That's all a record is. So these are the implementations. As a purely functional language, the way that it works is that you cannot, when you pass in data, you cannot mutate that data. You basically have to construct a new representation of data. You have to transform that data and give that back out. So the first one doesn't actually take any data. It just sets up the link. But the second one says, get the packet for this question. So question is this representation of a DNS question. And it goes in and it says, okay, all I'm going to do is I'm going to call the gen server. This means I'm going to call it synchronously, whereas cast is asynchronously. So I'm going to call in, I'm going to send it a message. And the message is a tuple with a get packet and then the packet that I want to answer. And it will call in and it'll do something and it will give me back a result. I will then wait for the result and return that back to the caller. Same thing for put. In this case, I'm basically caching the response. All right, and so I'm going to also do a call there. The sweep and clear are both run asynchronously. We don't have to wait for those to return. Basically, there's a timer that goes off like this. It says sweep now, and it's like, okay, just do it. And it does. That process does it as soon as the message gets pulled out of the mailbox. The mailbox is the part that you're basically waiting on. All right, so this is just a bit more. Erlang has my favorite thing about it is pattern matching. Pattern matching basically has, these are polymorphic functions is what they are. It says, if you call this function and it's an empty list, then do this, which is basically call the function again, but populate the list with some value. And this one says, if I call this function with a list with one value, then cool, do the logic in here. Now, if I call this function with a list, or let's say not even a list, let's say I call this function with an atom, which is basically just a name, it will actually blow up. So Erlang is designed to fail fast when you try to send a message or try to call a function that doesn't exist. And it will blow up spectacularly. Anyways, so moving on. So this initializes the packet cache. This gets a packet out of it. And all these slides will be up later so you can look through the code. But basically, this is all pattern matching. Like Erlang just comes down to pattern matching. All right, I look up from the database here, which is an in-memory database. If the t is greater than expires at, then I'll do, and it matches true, then I'll do this. If it matches false, I'll do this. In one case, I have an error, which is the cache expired. In the other, it's okay, and I give the response back. Otherwise, if nothing came back, that's any other default result, then I say, oop, cache miss, and then the caller knows what to do. There's the set packet. Same thing, basically, just it says, I need to push the packet into the cache. These are the actual implementations here. So it says, okay, here, I need the current time. I'm going to insert into the packet cache the question with the response and the time that it should blow up, should basically die from the cache, and then I'm going to reply back with the state. Now notice, so the thing that's cool about process in Erlang is that they contain state. So that's in Erlang because you can't pass around state. You have processes, and every process has its own state. And the state is passed in and returned after every function call. All right? So you know that there's no one else that will ever change that state while you're actually in that function call. Because that state is not mutable. Right? You have it there, and you know that no other function can be executed in parallel that will modify that state. And that's the reason, ladies and gentlemen, why Erlang is awesome for parallel processing. Because it gives you that layer of protection. You can do parallel processing in all kinds of languages, but Erlang is one of the few languages that enforces that very strictly. I'm going to skip by this for now. Closure. Because 2 languages isn't enough. You need a... Okay, so this is a bit of... I'm just kidding. I'm not going to go over closure today. I'm just messing with y'all. You can do that on your own. I do want to give you a couple links, though, here. If you want to learn Erlang, go learn you some Erlang. It's free. It's an online book. It's awesome. If you want to learn Go, do the tour at Golang. Both of these have been set up so that you can learn them fairly easily. And I highly recommend learning additional programming languages other than the one you're comfortable with because they're going to give you new ideas. They're going to make you think in a way that you haven't thought before, and they're going to help you find solutions to problems that you don't even know you have yet. Right? And you're going to be ready to tackle those problems because you understand other languages. So, in conclusion, Rails is good. Go and Erlang are good. Closure is good. Well, sort of, except as a VM. But what I suggest is you go forth and that you learn. And don't stick yourself into one technology. Learn different ways of doing things. Go forth and build stuff. Because learning only takes you half the way. You have to deploy something to production before you actually learn how to build real software. And then finally, launch. Actually, it's not finally. Launch is the third thing. You got to launch. This is above all. If there's only one thing that you take away from this talk today, just one, this is it. Ready? You guys got your pads and paper out. You know, this is the important one. Have fun. That's the one thing I want you to learn. If anything else, take that away from this. Thanks very much.